My new video. So today we're going to solve another question related to binary tree and its level order successor. So what exactly means by level order successor? Means suppose I have to find like what is the level order successor of 3 for 3. So level order successor for 3 is 4. So level order means like this: 1 and successor of 1 is 2. For 3 it's 4, right? So in this way, so level order successor of 3 is 4. Okay, so this is a level order. So I'm going to take queue data structure to solve this question. So this is my queue. This is a container, that is queue. Okay, so firstly I'm putting 1 into this one. 1. Similarly, so childs of 1 are 2 and 3. So we are checking like, is it the node for which we need the level order successor or not? So for 1 is not 3, so we are currently looking for 3. So 1 is not 3, so we can remove it. Okay, then and also we have to add childs in the queue. So for 2 the child nodes are 4 and 5. Now 2 is also not the key, 3, right? So we will remove this 2. Now we have 3 that matches the key. So what we can do, we know after 3 we are going to get our answer. So we'll remove this 3 from our current queue, and if we check the top of queue, that is going to be 4. So we just only have to check the next element for the key. So suppose we have to find out like what the successor level order successor for 3 so we just have to look for the next node after 3. So if we remove this node, if we remove 3, then the top element is going to be 4. So we can easily say that the top of queue is 4, and that is our answer. We need to return this 4. It's an easy one. So yeah, I hope you get it. If you have any problem or any doubt, you can ask that in comment. Okay, let's see its solution, its code. So this is a code. So we are taking a queue, we are pushing root at the starting, then we are checking the length of the queue. If it's not 0, then we are putting our first like the top of the queue in current node and removing that first node from queue at the same time. And now we are checking if the left of this node is null. If it's not, then we'll push into queue, and for similar for the right. And when we find out like what's like, if it's the current node is the key, so we have to break there, because now the top element is going to be our next like our level order successor. So we just have to like if the queue length is greater than 0, it means it's not null, right? So we just have to find the peak of that queue, top of that queue, and we just need to return that. Yep, that's all guys. Thank you so much.